I've received this stepper motor in for repair from Unis Group in the Netherlands. Okay, the first thing I do is make a copy of the Dutch repair form and put it into a folder for our repair number. Then I go over the basic checks and make sure the insulation is good. I double check the resistance of the phases, and then the thing that I have to do before I can dismantle it is I do a sinus test to make sure I know what voltage this motor will produce at 1000 RPM, so that when it's reassembled and I remagnetize it, I can make it produce that voltage or better again, so I know that the stepper motor is going to work when it arrives on site. We do this because most stepper motors we don't have any details for of what the back EMF values should be. We do have it for the Pacific Scientific and some other steppers, but not for everything. I have just done a sinus test on the motor and it produces 22 volts per phase RMS when it's rotated at 1000 RPM. So once I've dismantled this motor, changed the bearings, reassembled it, when I remagnetize it, I need to get 22 volts RMS again or above. The stronger the magnets, the more voltage will be generated when you rotate the motor. The motor is free to turn. You can feel the cogging of a stepper motor, but it's smooth, which means that it doesn't have any problems with alignment, locking up, spigots moving, so there are probably no problems internally, but I'll find out when I take it apart. Okay, the stepper motor is dismantled and I can see a problem straight away. One of the laminations of the rotor has come loose. I'll clean that up and I can possibly glue that in place. It's a very small rotor, so I would not like to remove the lamination because it would affect torque. You can see where it has been bouncing around inside. It has made a bit of a mess of the rest of the rotor laminations, and I don't know if you can see that it has done the same on the inside of the stator, so I need to sort that out first before we can worry about the basic repair and remagnetizing. So I'll do that now. Right, the stator has been cleaned up, the bearing housings have been cleaned. I have the bearings here. I'm going to book some new bearings out on KISS. The rotor I have cleaned and I've glued the lamination back in place, so I have to wait for the glue to set because remagnetizing it will try and rip that lamination back off, which I don't want. I'll take you over and show you the magnetizing fixture. Right, this is our magnetizer It has two terminals, positive and negative, a percentage reading scale, and it puts out about 8,000 joules through our magnetising fixture. And this is simply a solenoid coil. Yeah, the cable comes in here, goes round, 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 comes back out here. It's a simple solenoid coil. When we put a magnetic pulse through it, when we put power through it, one half of this will become, depending on how we have it connected, a north will be generated this end, for example, a south this end. We change the connections, it reverses the polarity. Very simple. Right, we have here the rotor out of a typical stepper motor. This has 3 stacks. 1, 2, 3. There's 3 magnets in here. The magnet is in the middle, the black bits. 1, 2, 3. This end, for example, on this motor would be a south. This one, a north. There's a separator in between, south, north. Separator, south, north. When we put this into here, what we're looking to do is magnetize these black magnets with a polarity south on this side, north on this side. This one the same, south on this side, north on this side. South on this side, north on this side. Or vice versa, doesn't matter. So what we've done when we did our sinus test is take a baseline reading of the amount of energy that this will produce when we do a sinus test, a back EMF test. When we dismantle it, these magnets demagnetize. So when we have finished the repair and we reassemble the motor, the whole motor is put into here, assembled, and then we set a percentage and we hit the remote button. This puts a big pulse through here and hopefully magnetizes these magnets. What we need to make sure is that we're getting the same or more voltage from the motor once the repair is complete than when it came in the door. We don't know if a customer has maybe dismantled this motor before we've got it. So it's possible that when we get it, it's already demagnetized. We'll find out with the stepper motor that we've been working on. Here is a stepper motor with the lamination replaced and glued in place and cleaned up, ready for its bearings.